No, the American ton. 2000 LBS, baby. Fuck your metric system. Gregory!
Anthony.
What's up, buddy?
Not too much, dude. How are you doing?
Ah, just another week in paradise.
Yeah. I
Looking.
actually completely lied 1,000%. I have just been up to my fucking earballs in work this past week, so.
That's what happens when you get a house. You gotta paint, you gotta fix, you gotta figure out all
Uh,
the stuff that the person that had it before you lied about.
yeah, exactly. So far, I haven't found any lies. Everything's been pretty solid in that respect. But, man, like, it's been a while since I've been in the painting game, and I forget how much prep goes in before you start painting a house.
Yeah. And you're not even
It's
doing the outside, you're doing the inside.
No, we're doing the inside of a 100-year-old house. So
No, that's true.
we look at a lot of the stuff and see that the last probably 3 times it's been painted, they have not done the prep either. So we found where the curtains are hung on the windows just looked like Swiss cheese. There's so
Curtains are
many
hung by
holes
the
where
chimney
all the
with care.
curtains up there.
Oh, yeah.
The curtains are. Why are you hanging curtains by the chimney?
Stockings, curtains, whatever. However the nursery rhyme
Same thing,
goes.
right?
Yeah, you
Oh,
gotta
but yeah,
patch all
that's
the
been
holes, and yeah, no, I'm sure
yeah,
it's. Yep.
patching all the holes.
It's all
We
plaster.
took all the wallpaper down
Oh,
in
finally.
that one room.
Yeah, not
That
fun.
took it took 3 of us a full day of work, and then one of us another day of work to get it
Yep.
all down.
Yeah,
It's terrible.
wallpaper is a pain.
Yeah,
I don't do wallpaper.
nah,
If
never,
wallpaper's there
never
and in
do
good
anything.
shape, it stays. You can see
Oh,
you
it
can't
wasn't
really
in
see
good
it.
shape at
You can't
all.
really see it in the background. That hallway has like wallpaper up the one side. It's never coming
Yeah,
off.
it's staying forever.
It's there now.
Yeah, no, I don't want to do it again. So you're gonna have to hire someone else other than me if you do want to take it down.
Nope, hard pass. This house is going to be sold with that 20, 30, 40 years from now. Well, you know
All
what
right.
makes peeling wallpaper more enjoyable?
I don't know, but
Bourbon.
could you tell me? Bourbon.
Bourbon.
Bourbon's the one.
Bourbon makes everything more enjoyable. And
Bourbon
we got
does.
ourselves a dark and mysterious one today, buddy.
We definitely do. Would you care to introduce today's?
I will be introducing today's. Absolutely. It is a 6-year Bibb and Tucker small batch double char. Get a
Double the char,
Yep.
double the fun.
Yep.
He's looking pretty good.
Yeah, so something neat about this one is unlike the other bourbons that we've done so far, this one
Mhm.
is actually out of Tennessee. It's out of
Ah,
Columbia,
Tennessee boy.
Tennessee. Yep. 88 proof, 44% ABV. This is their batch number 3. And again, it's a double char.
Mhm.
So as I hold on, let me just ready. Let me just.
Ooh.
It's nice.
Oh no.
Yeah,
Oh no.
yeah.
Oh no.
It's pretty in there
It's
because
in there real
I
good.
love the cork though. It's not like a topper. Like the whole thing is
No,
just
this is a
cork.
real cork. I kind of wish it was just a topper because it won't come out. Okay, all right. I got to twist a little bit. I think we should be good.
Yeah, get the pop. You gotta get the pop. Oh, that's
Ooh,
nice. Yours was
that
so
was so
good.
good.
So double char bourbon. It's they don't. I mean, technically they don't char the bourbon. Obviously, what they do is it's aged in a lighter cask. So
Mhm.
whenever you make bourbon, one of the things is that it has to be in a new oak cask, and those are always charred because that's what lets the bourbon into the wood and out of the wood.
Mhm.
There's 4 different levels of char. Fourth level of char is a lot of times they refer to it as like alligator char
Mhm.
because it looks like alligator skin if you've ever seen like a burnt piece of wood in a fireplace.
Yeah.
So this is probably aged in like a 1 or a 2, and then they move it to a heavily charred, probably a 4. We don't know; they don't
Mhm.
disclose this stuff. Probably a
No.
4 for its final aging, and that's where you get a lot more of the like smoky notes in the wood.
Mhm.
So I without trying it, I anticipate this tasting like wood, like very smoky
Yeah.
wood, to be the
Just
prominent.
charred, smoky wood. Maybe a little bit of vanilla. I'm hoping. How's it smell? Ooh.
The you can the smoke and the wood right off the rib. You can smell.
Yeah, I'm getting definitely getting the wood.
There is not. It's smooth though. Like I'm not getting a ton of burn off of it.
I'm not getting any actually. Like for a 6-year bourbon, that's pretty dang good. Doesn't tickle the nostrils at all, really, with the fusel alcohols.
That's good. Okay. All
Yep.
right, buddy. Cheers.
Cheers.
Yeah,
Mm-mm-mm.
smoking wood.
Yep, mostly wood.
You get some smoke. I get.
A little smoke.
I don't know that I. Yeah, I don't know that I want to say mostly wood. I am
No?
not. Yeah, I get a lot of the smoke. Well, I mean, define a lot of the smoke. I mean, it's not like a peated bourbon, but it's like smoky wood. It's not like just smoke.
Yeah, yeah, definitely. I see what you're saying. I mean, I do still think I'm getting mostly wood. It's mostly that kind of oakiness that you kind of want in your bourbon.
Well, it depends on who
Yeah,
you
it,
are.
it does kind of. Well,
You and
I kind of
you and
want in my
I,
bourbon.
no, you and I. This tastes a lot like the David E. Double Oak that you and I both
Hmm.
like.
I love that stuff.
Yeah, this is it's very smooth.
Hmm.
Not any. I'm not really getting a whole lot of like the. There's a touch of sweetness to it that I'm
There's a
getting,
touch, a little bit of like kind of dried fruit kind of stuff. There's
like
a
a
little bit
stone
of
fruit
that kind of
almost.
like almost more. I was thinking more of like a like raisiny, a little bit like that. But no, it's mostly the wood, and it finishes very clean. I like how clean this is finishing. It doesn't linger at
Yeah,
all.
you're right. And the little bit of burn that there is more tip of the tongue. It's not. I'm not getting that Tennessee hug or the Kentucky
No,
hug.
The
The
Kentucky
Kentucky hug.
hug,
No, it's more like the Tennessee tip of the tongue tickle.
the Tennessee tip tickle,
The Tennessee tongue tip tickle.
the
Say that.
Tennessee tip
Yeah,
tickler.
say Jesus fucking no. No. It doesn't help that the state itself is a bit phallic in shape.
Uh, no, it is now the Tennessee tip tickler.
The Tennessee tip tickler in reference specifically to the tongue.
Yep.
Yep,
Mm-hmm. Yep.
because the well the no, no, no.
Honestly, dude, you started it. I'm sorry.
Just dip your wick, if you will.
Dip your tip.
Uh, mm.
But
For
yeah,
those
no, this is
listening, not
very good.
watching, I just tried to stick my tongue into the Glencairn glass, but it was too far down and it looked weird.
Yeah, it did look weird. We're probably gonna cut that part out, but
Speaking to the regularly scheduled program, and speaking to those, I think this is here in what will probably be episode 7.
mhm.
Is a great time to tell people that if you want to hear all of the stuff that we say in between when we say, and now we're back, you can become a member on our Patreon. What did we end up naming them?
The Cask Strength
Yeah,
Club.
it's the
If I
yeah,
remember
you're right.
correctly.
It is in fact the Cast Strength Club.
I think it's a very fitting name for our group.
Unlock the full flavor of our unfiltered, uncut episodes with the Cast Strength Club. As a member, you'll enjoy raw, unedited conversations where we have deep dives into whiskey, liquor, lore, fascinating historical tales, get the whole story, with every drop of insight and banter, just like savoring a whiskey straight from the barrel, perfect for those who appreciate their podcasts like they like their spirits, bold and pure. We have one level, we're not at fancy over here, so if you want to become a member of the Patreon, you get the full 2 hours and change that we end up recording, totally
Mhm.
unedited. Please don't cancel
Yeah,
us.
yeah, please. This is really you have to understand that we like to joke a lot, and sometimes our jokes are a tad off color.
Oh, they
So
could be so much
we
worse.
it could be so
It
much
could be
worse,
so
but
much worse.
just for everybody to know out there, we appreciate you in advance for not canceling us.
Yep. Yeah, we do. And you essentially you're getting a full another episode a week if you're a
Hmm.
subscriber because we release weekly, record weekly, so you get the full, which is honestly close to double the length of a
Hmm.
normal released episode. So
Yeah, and I think honestly, we could probably talk about even releasing in advance on the Patreon.
it's not being
We'll see
promised,
what
but
happens.
maybe you might get them early and it might be
Maybe,
the full thing.
maybe. I mean, it'll definitely be the full thing. Whether it's early or not is the question.
It's a mystery. Greg, you know what else? It's a mystery, and is
Your
also
mother.
similar to our bourbon, dark, black, and mysterious.
The Tennessee Tip Tickler.
The Tennessee Tip Tickler. Now, the vast unknown of space, Greg,
Space.
which is
The final
which I believe is
frontier.
the theme of today's episode. Unlike well, the theme of this episode could easily be how much I actually love this bottle.
Yeah, no, this bottle is fantastic.
Like
It's
the
like
like the
old
beveled
school
glass.
medicine. It's like the medicine bottles of the past.
Yeah,
It's like a really nice bullet bourbon glass. Bottle.
this is the type of thing where like I'm totally okay with paying a little bit more for a bottle because the marketing's super cool. Like
Oh, I do that
these
all the
bottles
time.
cannot possibly be that cheap to make, but
No, not at all.
not
They have
not
to
compared to
definitely
a
get them.
normal not compared to like a normal like just glass bottle.
Yeah, especially since it has the Bib and Tucker like embossed on the front of it.
But anyway, back to
But
today's
yeah,
episode theme. So we
yeah,
figured double char, super dark, super mysterious flavors. What else is dark and mysterious? The vast unknown.
yeah. The vast reaches of our galaxy and the universe. Really, it's kind of crazy how big it is.
It's like that
It's like
Pete Holmes skit. Zoom out. You're not that important. You're standing on a rock floating in infinite nothingness. And that
Infinite
infinite
nothingness.
nothingness is expanding.
If the nothingness gets bigger, tell me how that works. There's more nothing as time's going on.
Oh, man. Okay,
Yeah.
so there, I mean, we could start this pretty much anywhere.
Hmm.
Before we really dive in, I
Hmm.
need you to give me like a plus minus on how long I'm allowed to talk about aliens.
About aliens?
Yeah, like how much, like I don't want to start there. I just like before we get going, because like I'm almost done with my first glass, so I think it's important that I anchor in my mind right now how long you'd like to talk about aliens during this episode.
How long? Oh,
Yeah,
Jesus.
yeah, yeah. No, just yeah.
Well,
While you're thinking.
we should honestly do a whole episode of conspiracy theories.
Yeah. Oh
That
no,
would be
we
fun.
definitely will, because I have like my absolute favorites.
All of them.
Yeah. Well, they're most of them are good.
So I'm thinking for aliens,
Like 5 minutes?
let's
Like
let's
five
give
minutes on
me
alien? You're gonna give
let's
me
give me
more?
way more than that.
Jesus.
I think aliens are really cool.
Well, I think aliens are really cool too, but
Um,
there's, I mean, I'd like to talk about things that we know are real
I'm
more
thinking
than the things that
let's
I know are real.
let's talk about things that are definitely real for a while, and then we'll end with the
We'll
aliens
trail off on
because
Nibiru
I
and the
have.
Anunnaki and the
All right, maybe we will limit the amount of times. I
yeah,
have
see,
no
no,
idea what
I
the
just
fuck
need
I'm
to
talking
I
about.
need you to know what you're getting into when you're giving
Yeah,
me okay.
yeah. Well, our Patreon users will know what was actually got into when we released this episode.
Yeah,
Or
I want to start with a trivia question.
you want to start with a
I
trivia
want to start with a
question? All right,
trivia
let's do it.
question.
Let's do it. Let's do some trivia.
Greg, what was the first man-made object in space?
The first man-made object in space. I think I know this one actually.
Oh wait. Oh, are you gonna ruin it? Yeah. Okay. What was the first man-made object in space? Because I know what our listeners are
I
probably screaming right now.
what do you think our listeners
Hmm.
are screaming? Oh, you want
This
me
is
to
a
go
question
first?
for you. This is a question for you.
I believe it's a manhole cover,
It's a
isn't it?
manhole cover. I wanted you to
Yeah.
say Sputnik 1 so bad.
No, no.
Officially,
I've heard this before. Yeah.
officially it's Sputnik 1. So I'm not
Officially.
so you've heard this. So I'm not telling this to you, but for everyone out there listening right
Yeah.
now that said, "Oh, I know this one. It's Sputnik 1. It's the Russians." Not the Russians. In 1957, like 6 months before Sputnik 1 was launched, I think it was in the
Mhm.
same year, the US this was testing nuclear weapons, and they thought, let's set one off in a big 400-foot hole in the ground, and
Mhm.
let's weld a manhole cover over the top of
Yeah.
the hole. Well, nuclear bombs explode with like a lot of force, and
Ah.
all the expanding gas and whatnot, it shot off, and they were recording the top of the hole at some ridiculous frames per second. So they don't actually know how fast the manhole cover was going. They just know that it was going at least 140,000 miles per hour because they only caught it for one frame. You need to catch something for 2 frames
To
to
know
figure
how
out how fast it
it's
was going. So all they could figure for sure was that it was going at least. For any of you that don't know what escape velocity is, that's the speed you have to go to exit Earth's gravity.
And what is escape velocity?
That no, well, I don't. I could do the reverse math, but it was going roughly 6 times escape velocity. Again,
Oh, gee.
at least.
At least 6 times escape velocity. So it is thoroughly.
Yeah, and so that
space.
there's a lot. If you read the story, if you Google it, it's conflicting because there are people that say that it would have burned up in the atmosphere, but it was steel. It was a steel plate, and you have to remember at those speeds, it would have spent from ground to upper atmosphere. We're not talking minutes going through the atmosphere. We're talking seconds going through the atmosphere.
Which actually invites me to believe more so that it might have actually burnt up in the atmosphere.
But you still have to
Because of the
accumulate
friction.
heat. No, but you still have to accumulate heat for it to have burned up. Like you would have cleared the atmosphere before. Okay, so did you watch the last episode of The Martian where they like put the tarp over? It's like aerodynamics. Like we're gonna be out of atmosphere so fast that
The
aerodynamics
last
isn't gonna matter.
wait, you mean the movie The
The
Martian?
movie The Martian. It's like prolonged. You burn up in the atmosphere from like prolonged exposure to the heat from the friction. But if you clear the atmosphere in literally a couple seconds, like You got to think how fast space is. Only the International Space Station is only like what 98 miles up, something like
Yeah,
not
I mean,
very far.
I'm just trying to math it because like,
It's
or
like
not
6
even math,
seconds max.
but I'm trying to think because like just because you're not there for a long time, it's still like a friction thing. So you're still gonna have to move against all of the air at one point or another. So you're still gonna accumulate the same amount of friction just in a quicker period of time.
No, that's not how the physics works.
That might be how the physics works. Either way,
I don't I
first thing in space, manhole cover.
most people will agree that they think that it now not the
I think it's
fastest
in space.
object in space. I think it's in space too. I mean, we're not talking a regular manhole cover. We're talking about something they thought may or may not contain a nuclear explosion.
Exactly.
This
Yeah,
isn't
no,
this isn't your no this was
it's
a
not
thick
like
this was a thick
New
boy.
York City block kind of. No,
No,
is
this was
gonna
a
be
thick
something.
boy.
This is a thick plate that we just call a manhole cover.
Yeah. But and then so Americans accidentally did in fact beat the Russians for first object into space.
Ooh, America.
America.
Something neat.
Now, the Russians did win most of the other things. First man in space, Yuri Gagarin. Who was the first American in space? Alan Shepard? That sounds right.
I honestly do not know these particular trivia questions. I know.
I like the early space race. It was just America's way of trying to bankrupt the USSR.
It's funny because I think you're looking at space as like the history part of space. I look at space as more the science part of space.
No. And I love the science part. Science part's fantastic.
Yeah.
I'm just saying, like, I think it's important to know that we did, in fact, win to get the first people and the moon landing was
the important part.
We can certainly talk about the moon landing during the conspiracy theories episode, but we did in fact land on the moon.
We most definitely landed on the moon.
That was that was the first foray into putting man-made objects in, and had we not started doing that, we would have never gotten like the Hubble telescope or James Webb like up in rotation, and we would never get these mind-boggling pictures and research and proof of these other objects that we have that we do now.
But honestly, from a science perspective, there's like you're talking about the James Webb telescope. I mean, before Hubble, that's just like I feel like opened our eyes literally and figuratively to what is actually out there, and to be able to actually see all of these things that we thought were there and could theorize were there, but we couldn't actually know if it was there until we actually get some kind of proof about it, you know?
Yeah.
So all these viewing devices were just allowing us to be able to actually see all of this stuff.
What's mind-blowing to me is that some of the things, not a lot of stuff, but some of the space phenomenons, even some of the ones we still haven't like quite totally figured out, like if you want to talk about like dark matter and dark energy, we have like you have the theoretical like mathematical side where you like Einstein was a great example. Like he called it his like greatest blunder, but he was like in one of his equations he was like factoring in like a number, and I don't remember the full story, but it was essentially he was calculating for dark matter and was right.
Yes, probably every calculation he was doing was probably off by a certain number. And it was probably the constant, and that constant was probably just taking into account the dark matter in the equation.
Yeah, and basically it was like he called it like his greatest blunder, but it turned out that he was like 100% right and never really knew that he was his biggest blunder was thinking he was wrong.
Yeah, that sounds like it would be Einstein's biggest blunder.
Which I mean, it's wild to me that they still don't have like a super great explanation for dark matter and dark energy. I get it. It's like space is big.
Well, it's not even space is big. It's that like it's literally exists in like a place that we can't really get to, and we literally can't see it.
Yeah.
And it's not possible to grasp. Like everything in our whole existence is made of matter, really. And it's literally the polar opposite of what everything is that we are, and that everything is that surrounds us. So how could we get a grasp on what it is using instrumentation that is made of the opposite of what it is, you know? I mean, I'm no physicist, so I definitely don't know all that much about this kind of stuff, but it's like trying to see an electron with a light microscope, to bring this to biology. With the light microscope, you can only see things that are the size of a photon. And if you're going into something smaller than a photon, you can't possibly see it with a light microscope.
Roughly the same size, but yeah.
A little smaller.
You're about the same.
Yeah, get out of here.
Well, now we have electron microscopes, which is even...
But now we have electron microscopes,
neat.
so you can see see atoms and stuff like
Yeah,
that.
I
But
think it's wild
it's
that it's like
impossible to illuminate something that's the size of the thing that you're looking at.
yeah. I still think it's absolutely wild that it's like mid 20s. It's like 20 something, like calculated wise. It's like 20
Mhm.
something percent of the mass of the universe. And you just have no fucking clue. Because it's like, like one of the main ways that they look at it is like the way that galaxies rotate
Mhm.
is like it's like there's a certain speed that they should rotate. But at the speed that the ones that we observe, at the speed that they're rotating, spiral galaxies at least, they
Mhm.
should come apart, but
Mhm.
they don't because there's like a quarter of its mass that we can't fucking see.
Some kind of force that's holding it together in the
Yeah,
middle.
because
Yeah.
the mass is
The
there's
super
there's
black hole in the middle.
yeah
Yeah.
there's the gravity that we're not accounting for. That's another. I mean, it was
That's
originally
that is a thing
theorized.
that people think potentially is in the
Well,
middle of
every
galaxies.
galaxy has a supermassive black hole in the middle. Every galaxy we've observed has a super, including our
Mhm.
own Sagittarius A star, fucking
Mhm.
supermassive black hole right in the middle. All of
Yeah.
them, which makes
Well, I
complete
mean,
sense.
we can say that, but it's also we didn't even see black holes until moderately recently. Was it 2018, I think, when we actually saw one?
Well, when you say saw one, do you mean like
Hmm.
took a picture of or like
Uh,
knew there was one there?
no, took a
Because that was
picture.
what.
I'm talking about took a picture.
Well,
That's what I'm
I
talking
mean,
about, like the whole
yes,
measurable
sort
thing.
of
Like
took a picture, and
we
you
know
can't
it's
still
there
you can't you can only take a picture of what. That's the thing
of
is
the
you can
event
only take a
horizon.
picture of
Yeah,
what's
you can't
around it.
because the light doesn't escape, so it's impossible.
Yes, we proved black holes well before that though, because you can see the movement of you can see that you can't see
Yeah.
anything and then see how everything's interacting. Like if you were to take a black hole the same mass as the sun and
Hmm.
just swap them out, nothing would change. Like
Oh, the same masses.
yeah, the same mass
Sorry,
as the
sorry.
sun. Now you now
When I was thinking the same size as the sun, and I'm like, the whole world would everything would implode. That would
no,
be a
just with the
giant
same
black hole.
yeah, if you I mean our sun can't make a black hole. Like it's not enough mass. You need like
No, but I'm
3.4 solar masses during a collapse.
yeah, but I'm
Give or
saying
take.
like if you had a black hole the size of our sun and switched it out, I mass of the sun, yes, completely correct
Yep,
because
because that's how physics works.
that's how physics works. Yeah, that's gravity right there. But yeah, no, if you had one that was the mass of our sun, it would or the size of our sun, it would just absorb everything in the general vicinity of it.
Yeah. Well, like contrary to like they're not vacuums. Like they don't like if you're outside the event horizon and you can just and like your trajectory is tangential. Like you can just orbit. Like all the stars in the center of the galaxy, like they're just orbiting the black hole. They're not
Yeah,
like actively getting sucked in.
it's just something. It's something that is such has so much dense mass that its gravitational pull is strong enough that light can't escape it.
Yeah, but like
That's like the
at a
definition.
certain point, like you
Yeah,
want yeah
like you said, the event horizon. But it's just like anything. Gravity is a function of distance. So the further you get away from the mass, the less the effect of gravity is on whatever it is.
I there's a lot of fun theories about like black holes and so if you were to
Hmm.
fall into like a small black hole if you fell in
Hmm.
you would get spaghettified.
Spaghettified.
Yeah,
Just
because
turn into spaghetti.
yeah, so past the event horizon you get as you get closer to the singularity
Mhm.
you will approach the speed of light faster and faster.
So I'm
But
gonna pause you real quick. So just some definitions because we're throwing shit around a lot. Event horizon, it's kind of called the point of no return, like we're saying. It's the point that you can still get away from a black hole's gravitational pull, and then if you cross that boundary, that event horizon, you're going into the black hole.
yep.
That is your option. Then you've got the singularity. That's the center of the black hole, the singular point of all of the mass, and where the biggest gravitational effect is, and where the rest of the gravitational effect is radiating from. So that's kind of the two main things. And then if we want to do, I've got one more definition that I don't know if we're going to get into. We probably will because it's kind of cool. But it's something called the accretion disk.
I
Uh,
love accretion disk.
so that's literally just all of the random matter that is orbiting the black hole that has not actually crossed the event horizon yet, but is still captured in its gravitational pull. So it's orbiting it and slowly descending into it until it hits the event horizon and gets sucked in and spaghettified, apparently.
Well, so not necessarily. Depends on how big the black hole is.
Oh, okay, sorry, not all of them will
Yeah.
spaghettify you.
So some are so big that
Hmm.
the distance between the event horizon and the singularity is so far, because that's
Hmm.
the thing is, as you approach the singularity, you approach the speed of light,
Hmm.
as it's like sucking you in.
Yeah.
So your feet are closer to the singularity than your head. Like, so if it's a smaller black hole, the ratio of distance is smaller, so it'll pull just ever so slightly harder on your feet than the top of you, and will literally
Ooh,
stretch you
ooh,
out. Now you're not going to feel
ooh.
any of this because you're in
You're
space
gonna
and
be
you're dead.
very dead already. Yeah.
But super, like, really big, super massive black holes, there's enough gap between the event horizon and the singularity that you will just sort of like float in. But what's really cool is Einstein's theory of special relativity kicks in, to where the
Hmm.
faster you move, the slower time moves for you as a function.
Hmm. Yeah.
So if somebody's watching you fall into the black hole, as you approach the speed of light, to them it's going to look instantaneous, but to you it's going to feel like a really long
Literally
period of
forever.
time.
Because if you're approaching the speed of light, then it's just gonna be like a limit of time. So it'll probably feel like forever.
Yeah, you'll already be dead, but from an outsider's perspective, if they could see in, it would take you
Hmm.
in eternity
Instant
to fall in.
for
No,
you,
sorry,
but for
sorry,
an
no,
outsider
no,
perspective, it'd
sorry,
be
I
an
flipped it.
instant.
I flipped it.
Yeah.
For you, it's gonna feel instantaneous. For them, it's gonna look like it's taking forever. No, I
Other way
was right
around.
the first time. I was
Other way,
right the
you had it
first
right the
time.
first time. Yeah.
Yeah,
Special relativity is relative to whatever is moving.
yeah. I'm glad that you brought up accretion discs too, though, because
Yeah.
so my second favorite, not well, I don't know if it's my favorite or second favorite, one of my favorite like spatial phenomenon that really didn't get discovered until like the 60s, when we started like really looking into space, are
Hmm.
quasars.
Really? Yeah.
Yeah, which are
That's
literally
really cool.
just, yeah, quasars are just huge black holes that are sucking in a ton of matter, and all of that matter that's swirling around the event horizon gets so hot that
Hmm.
it emits light, and they quasars are, other than supernovas, and depending on the size of the quasar, they could be brighter than even some supernovas, some of the brightest objects
Hmm.
in space.
Yeah.
Quasars are like stupid bright.
Really.
Yeah.
So it's like multiple. So it's multiple black holes spinning around, and then they're. Wait, is it multiple black holes? Did you
No, it's
say?
just one black hole. So like when stuff's
Uh.
falling in and it's rotating around and it's creating that accretion disk, those
Hmm.
accretion for the largest black holes, those accretion disks are so
Uh.
bright that they form what are called quasars, which are
Okay, I get it.
which
I
are
get it now.
just like unimaginably bright.
That's
Like
so interesting to think. Like
unimaginably bright.
it's so interesting to think about them spinning around and emitting that much light, and then at the very center of it, all of the light is getting pulled into it. So
Yeah,
it's like
yeah, it's all before it gets in.
the outside edge is like emitting all this crazy light, but the inside can't escape the black hole's gravitational pull. That's pretty fucking
Nope,
cool.
and that's why they look so cool. It's because it's
Hmm.
just this incredibly bright light
Yeah.
surrounding, like, when they first saw them, they weren't sure that they were black holes that were doing it, because the instruments that we had at the time weren't necessarily good enough to see the the dark black hole of a center. It was getting
Hmm.
washed out by how bright the shit falling in is.
This is so. I just am looking up pictures of
Quasars?
quasars now.
Yeah, they're nuts, dude.
Yeah, so I'm sure these are all artist renderings, but think of a hurricane, except all of the clouds are extremely brightly lit, and then the very center is just a solid black hole where the eye of the storm would be. It's pretty friggin' sweet. Let's see GWST.
This
Oh, I
is,
see it.
yeah.
Oh, that's super cool.
Yeah, but so it's just, so you're seeing four of them, but it's actually
Mhm.
just one. It's a gravitational lens. For those that don't know what gravitational lenses are, it's when you're looking at something really far away. It's a single object, but as we learned again from Einstein, thank you, sir, light can bend. So you can actually use natural gravitational lenses, which are pockets of mass in between you and the object you want to observe. It can be
Mhm.
galaxies, it could be galaxy clusters, depends on how far you're looking, but the light from the distant objects will actually bend around it and create that effect where you're seeing multiple of them, even though it's just one thing.
So there's just things in the way between us and that quasar
Yep.
that are causing the light to bend around. So we now have four little dots, but it's just one.
Yep. It's actually a quadruple lensed quasar.
Ugh,
That is so cool. I wonder if
that is
Astro
cool.
Alexandria has covered that yet. Like I think we talked about her in the internet episode.
I think so.
One of my absolute favorite creators on TikTok. Like she just talks about space and space stuff and like shows the JWST pictures and everything else.
Yeah, I remember when they were launching JWST, I was just like glued to it all the
Mm-hmm.
time, watching them, like all of the progress with it, all of them talking about, all right, now this, the things that block the sun that open up, that they had to like, because JWST was so big, they had to send it up all folded. And then once it got up into space, they actually had a different sequence that they had to follow that allowed it to unfold to actually how it's supposed to be to actually see everything.
Mm-hmm.
So, because the telescope is so freaking powerful, even the light from our sun being behind it would interfere with the pictures it took. So it has this massive, like solar block on the back. I can't remember the name of it right now. But it all had to unfold uh, in space because it's so big.
Yeah.
And I imagine being on that team that designed it and having to be the ones that are kind of like punching in the codes to get it to actually start unfolding in space and just being like, please tell me I didn't miss a screw. Please tell me I didn't miss a screw. I pulled that cotter pin, right? I like armed it correctly, right? But yeah,
Oh, that had to have been.
I was
I
just
do remember
watching
when they
like
launched it.
everything that was being done. Hmm?
The first images that came out of it were so cool. Like, was it the?
Yeah.
I think the one you said you like are the Pillars of Creation.
Yes, the
That
Pillars
was
of when
such a good
he did the
picture.
Pillars of Creation picture. Because I
Oh,
mean
that's such a good
like
picture.
when Hubble went out and took that picture first, it was like that was a big deal. Like that
Yeah,
was like one of the coolest thing that had ever come out of a space telescope. And then they had JWST do it, and it was like you thought it was cool before. Now look
yeah,
at
and it's just. I
it.
mean, it's just such a cool nebula,
Hmm.
and it's JWST is letting us look into like because it has like its infrareds and everything, and
Hmm.
it can view in all those different wavelengths. We're literally watching. Like Hubble was good, but like JWST is literally letting us watch star creation and like
Hmm.
galaxy creation because
Yeah.
so like again I'm not going to assume that our listeners know a shit ton about space. Like nebulas are big clouds of gas and dust in space, and uh, they're affectionately referred to as star nurseries
Hmm.
because as gas kind of clumps up, it attracts more and more gravity and more and more gravity and more and more gravity, until eventually it has enough mass that it ignites and becomes a
Hmm.
star. And there's tons of failed stars
Hmm.
that just float around space that never got enough mass to ignite. I forget what they're called. Proto stars? Proto? No,
Hmm. I think it is
it's
protostars.
something like that. But
Because
yeah,
well, proto no, well, I mean it might not be proto because protostars are just the what you're talking about, the big clumps of mass before they actually quote unquote ignite. It's like the precursor to stars.
then that is what I'm
Um,
talking about then. Because some of them never ignite.
yeah. Yeah, and it's also interesting because we say ignite because it's like it's easier to think about it in terms of like lighting something on fire. What's actually happening is there's enough pressure and gravity to heat to create nuclear fusion in the core of this whole thing. So it's really more setting up a nuclear fusion reactor is
Yeah,
what it has to have enough mass to do that.
but in space.
So, but in space,
But in space.
in a space nuclear fusion
Yeah.
reactor.
The other natural space phenomena that I really like are pulsars.
Pulsars are pretty cool. So pulsars are ones that I was definitely looking at. I don't really know all that much about them though. I mean, do you?
You can set your watch to that shit.
Yeah.
So they are rapidly spinning neutron stars that
Hmm.
typically have like two emitting beams of radiation. So
Hmm.
they have a regular period in which they rotate, and it's incredibly consistent. What makes them hard to find is they don't emit a ton of light because they're neutron stars. So
Hmm.
when you have really big regular stars, whenever they die, they typically shed their outer layer And then what's happening is that there's not enough fusionable material left to, so stars are basically always constantly fighting themselves. Like their mass wants to shrink them in, but the
Hmm.
fact that there's constant nuclear fusion going on is expanding them out. So it's a balancing act for basically the entire life of the star. At the
Hmm.
end is when it's running out of fusionable material, and all of the things that we're made out of are all created. All the heavier elements in the universe are created
Hmm.
in older stars that are about to die, and they're
Hmm.
just trying to combine all the shit that they can
Yeah,
just to
it's
stay
just
afloat.
mass. Yeah. It's like
But
mass just trying to take mercury and melt it into something else, and it won't melt. Lead doesn't get more than lead usually.
well, yeah,
So,
well, it's the because after, I think it's, is it after carbon? It's either after carbon, it's one of the lighter elements, but after one of
Mhm.
those elements, the fusion's no longer a net energy positive. It's an energy drain. It takes more energy to create it than it releases when you create it.
Yeah, I'm not sure where, because I mean, when I think of fusion, I'm still generally thinking hydrogen because that's usually what we would use for fusion because it
100%.
takes the lowest energy to get it started and it
And
emits
it's
the most amount.
admits the, exactly, and that's why, like, that's most stars. It's like hydrogen, helium,
Hmm.
like those are the most
Yeah.
abundant. But once you get to a certain element, it's no longer an energy positive reaction, and
Hmm.
that's like the beginning of the fucking end for the stars.
Yeah,
So they
and
collapse.
then you get a neutron star.
So if you're I think it's 3.4 solar masses. And when I say solar mass, I mean like humans always do. We take what we know, we multiply it, and we make that a standard fucking unit. So 3.4 solar masses is
Unless
the
you're the US and then you just make up fucking standard units as you go. You don't have to know anything. You just say an inch, 12 inches in a foot.
anyway. If you're 3.4 solar masses, it's I think that's right. Don't, you can't quote me on that. But I think it's like 3.4 is like the minimum to become
Hmm.
a black hole, because one of two things happens. Well, I guess there's a bunch of things that happen, but if you're between the mass of the sun and bigger, but not quite enough to make a black hole, it collapses, but it's
Hmm.
not enough residual mass to collapse it all the way down to a singularity, which would make it a black hole.
Black
So
hole.
what happens for a neutron star is it's literally just one big fucking neutron. The mass is so aggressive that it
Hmm.
literally squashes the protons and electrons together. A neutron star is literally so dense that it's essentially made out of all neutrons. Like the electrons no longer
Wait.
orbit. It's just fucking neutrons. That's why it's called a neutron star.
But how is it just? But well, neutron is a completely different particle than a proton and an electron.
Yeah, you have the neutrons, but it so all particles have their charges.
Uh-huh, yeah.
So like you have your protons, your neutrons, and your electrons in a
Oh, so the
stable
protons.
molecule. And yeah, you have in a
Okay.
stable sorry, in a stable atom, you have as many electrons as you do, unless you're an isotope, you have the same number of electrons as you do protons, because most atoms are neutral charge. When the star collapses, the gravity is so intense, but not intense enough to make a singularity, that the electrons stop orbiting, get sucked into the atoms, and cancel out the charges of the protons.
So it's literally just a
Big fucking
giant
neutron.
mass of fucking, or it's just a giant mass of particles that's completely neutral. So it's just
Literally, by definition, a
neutral,
neutron.
just a neutral particle,
It's
but
neutron.
except
That's
lots of
the
particles.
and there's quarks, and like, look, there's other stuff.
You're a quark,
You're a
you son
quark.
of a quark.
Up
You're a quark.
I'd be a certain communities, I'm a bottom quark.
I'm a charmed quark.
Top, yeah, I hate up quark, down quark, bottom quark, charmed quark. I
There's
fucking,
also, I think, a love
there
quark, isn't
is.
there?
I hate
Yeah.
the people that name quarks, by the
They
way.
just made shit up as they went.
No, my god, I really do hate quarks.
I don't think we should get into quarks. Now we're getting into
No,
small
that's too
physics.
physics. I do know, if you were to like take a spoonful of a neutron star, like put it on Earth, it would just turn the Earth into Swiss cheese.
Gravity.
Yeah, the intense pressure inside neutron stars forces protons and electrons to merge together to form neutrons, making up 90% of the star's composition. A
Wow, so the
teaspoon,
protons and the electrons actually merge?
yeah, that's what I was saying. Like literally
Hmm.
they smash them together, they cancel their charges out, and they just become neutrons.
Weird.
Yeah. A teaspoon of a neutral star would weigh 10 million tons. Put that into perspective. Infinite nothingness, and that nothingness is getting bigger. Yeah, 10 million tons.
Oh, in a
20
teaspoon.
million pounds in a freedom units.
Yeah, and
No, I'm
and that
sorry.
still doesn't mean anything.
No. 200. A ton is 2,000. So
Okay.
200.
How much
How
is
many
10,000
zeros?
pounds?
10 million tons times 2,000. 10 million times 2,000 is
Wait, you said it's already a ton, so it's 10 oh, so
2
times 2,000.
billion, right? I'm adding three zeros.
Yes, three zeros.
Yeah. I just wanted to convert
Jesus.
it. I just wanted to convert it to freedom units.
Why? Just leave it alone. No one likes freedom units. Especially not in this world. In this science world, we hate freedom units with a
No,
passion.
they are the devil to
We do not
calculations.
use them. We do not use them at all.
Dude, nothing bugs me more than when people talk about the speed of light in feet per second. I'm like, shut
It's
the
like
fuck up.
it's a nice number in meters per second.
Do you like how completely unrelated? Do you like? I mean, it's super related actually. For Star Wars, the Kessel Run,
Uh-huh.
they like had to rework what the Kessel Run was to make it sound less stupid. That they did it in like was it
Like
7
parsecs.
parsecs?
Yeah,
Yeah,
something
because
like yeah.
parsecs is a distance of length, not time.
Yeah,
So
exactly.
they
Yeah,
had
no,
to like rework it,
they just made shit up when they did it the first time in the original Star Wars. And then they're
and
like, wait a second.
and then the science community called it on it. So it was it Solo? I think it was in
I think
Solo.
it was in Solo, yeah, because it was in Solo since it was his story because they were just talking about the Kessel Run.
Yeah, and it was like a
Uh,
star. There's like it wasn't a time thing. It was a plot that they had through a nebula
distance,
that was
exactly.
less parsecs because it's. I
Yeah,
mean, good for them.
they
Like
just had
they
to make it
fixed
more
it,
convoluted to make it work.
make it more convoluted to make it less wrong.
Yeah, exactly. They like figured out a way to shrink the times or the space to make it actually a distance thing, not a time thing.
That's when they did that. I was like, first of all, good for you. Second of all, you must have definitely caught some internet flack that we don't know about. All of that started because I was talking about pulsars, which are neutron
Yeah.
stars that rotate really fast and like shoot beams of energy out either way. So it's like woo, 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 woo. And you like radio telescopes, you can hear them, and
Mhm,
it's like that's why they call them pulsars, is because we heard them before we could see them. And it was
mhm.
just like we were trying to figure out what the fuck is this metronome bullshit.
I mean, so wait, with them, does the sound waves they go out in all directions for them, but the light waves only go out in like the beam?
Well, there's no sound waves because it's space.
But then how do you hear them?
I'm saying like it in a radio telescope, like a
Oh,
radio
you hear the
telescope, you hear the electromagnetic waves coming from the pulsars, but it's not
okay.
all directions. It's literally like ejection beams, and it's just because there's a lot of pulsars
Mhm.
we'll never be able to see because they're rotating on an axis not
A
facing
different
Earth.
way that's never gonna point to
Never
us.
gonna face us. We're never gonna see
Yeah,
them.
yeah. I like I said, pulsars like I've looked into them a little bit, but I've never really delved into them too much because I again was trying to find the things that I find most interesting in space, and I think the thing that I think is the most interesting in
Okay.
space are all of the exoplanets we're finding and all of the planets that we're
Ah,
finding that could potentially support life. Just finding stuffs in that little Goldilocks zone, which, to our listeners, there's a distance from stars that planets can orbit that will give them the correct amount of pretty much make them the right temperature to support liquid water. And that is pretty much what we call our Goldilocks zone. It's where a planet could be habitable by life as we know it, because you have to kind of put an asterisk there because all of this stuff that we're talking about when it comes to life is generally like carbon based life forms that are similar to what we have on Earth. Now, we have such a small sample size and there are so many planets that there could be life that we couldn't even fathom. But that's what we know and that's what we stick to. And so we look for planets in this Goldilocks zone that could potentially have life on them or could sustain life if, for instance, we somehow were able to colonize outside of our own star system. So
do you know how they
I
first
just think it's
found?
so.
Do you know how they first found like exoplanets as a whole?
No,
Like
go for it.
it's Star Wobble,
The wibbly wobblies,
the Wibbly Wobblies.
the wibbly wobbly timey wimey stuff.
So it's we're
Wait. Do you watch Doctor Who?
no
Oh no.
sorry internet.
Oh no.
Like I've watched Doctor. So like
Uh-huh.
I've watched Doctor Who.
Yeah.
I'm not someone that regularly watches or has watched all of Doctor Who.
Okay. Well, that's where the wibbly wobbly timey wimey thing comes from.
I thought we were doing like a weebly wobbly thing. Like
No, no, that's something Doctor Who says.
weebles they wobble, but the star don't fall down.
Hopefully.
Yeah.
Anyway,
It was originally like theorized. So now we find them using that and like really sensitive photo lenses.
well,
But they
now we
use the
have
wobble.
telescopes that are strong enough that are we can actually not only just see them, but we can measure the light coming off of them with
Hmm.
our different lenses and stuff to see if there's liquid, like what kind of elemental composition that they have.
Yep.
So then we can potentially see if it's like a rocky planet like what we live on, if it's a gas planet like Mars or not Mars, like Jupiter or Saturn or Uranus or any of those. And you can actually see that by the different wavelengths of light that are coming off of
Yeah.
the planets themselves.
Which I still think is nuts because it's you're looking at light off of an exoplanet reflecting from a star
Uh huh.
that's like, I mean, the closest ones with a grain of salt, it's only like 5, 6, 7. What's the closest one? Like 4 and change light years away? Like the closest like Goldilocks one that we
It's either
found.
4 or 6. I think
It's
Oh, I can't
I'm
remember the name
blanking on
of
the
it.
name of it. I know which one
It's
you're
not just
talking about.
Planet
It's like
X, right? It's something
no, we
like
found
it's
one
something like
closer.
that.
No, we found one closer pretty
Um,
recently. Well, 2018 is when we launched TESS.
Tess.
TESS is so okay. So Hubble was like looking for exoplanets before. Hubble mostly looked for like dimming of the light of a star. So like if you were looking at a star and the exoplanet crossed in front of it, it would be like the brief dimming of light.
Hmm.
So that's one way they would find them,
That
and then
was
the other way they
that
would
was
find
like
them
the
was
wobbly stuff.
yeah. The other
Yeah.
well, no, well the wobble part is you can actually if stars have things. We're now finding that basically every star has planets orbiting it. It's just sort of
Yeah.
we're not special. It's how it works.
Closest known exoplanet. I looked it up. It's Proxima Centauri. I knew that.
No, that's the closest star. But which do we think? Other does
Mm.
Proxima Centauri have planets in
Proxima
the Goldilocks
Centauri
zone?
b is it's Proxima Centauri b. Yeah, so it's the closest star,
That's the
and the
closest star.
planet
But are we sure it has
the
planets?
planet is B. Yeah, it's Proxima Centauri
Okay, so
b.
it's just named after. Okay, got it.
Yeah.
Well, it probably has a closer. There's probably a Proxima Centauri A that is too
Uh,
close to support life.
B
Well,
orbital.
okay, but you didn't say how close it was. How
Yep,
close
yep,
is
it
it?
is. Yeah, it is in the habitable zone.
How close is it though?
It's 4.2 light
Oh, we
years.
were
So we
close.
were right. We were
Yeah,
right. And yeah, it is in the habitable zone too.
yeah. So what with the star wobble, when you have two objects orbiting each other, if they're of equal mass, they'll rotate around. If one's of lesser mass, it'll like rotate and the other one will do smaller circles. And if you have something like the planets and the sun who are so obscenely different in their mass, the sun's not actually sitting still. The sun's technically in a binary system with every other planet, and it does little tiny circles. And so it literally moves back and forth like just a little bit.
Hmm.
And we can see that in like distant stars if they have planets or other things orbiting them. There were
Hmm.
some stars that we were watching for a long time that we didn't know what was orbiting them, and it turns out it was a neutron star that we couldn't see. We couldn't figure out why it was doing the
Moving a
circles.
lot.
Yeah, we're not even gonna talk. We're not even
Interesting.
gonna talk about when neutron stars strip the gases off of like their twin stars and then collapse into black holes.
When they do their little spinny dance thing, and then
Yeah,
they
they do their little spinny dance thing, and then
uh-huh, yeah,
eventually enough mass is
yeah.
siphoned off to finally collapse it into a black hole.
Because don't at that point they become pulsars because they just emit crazy. It might not be necessarily a
Now there's a
pulsar, but I
different
know when they're spinning, they emit like this crazy radiation.
there's a different
Um,
word for there's a different word for those ones. Well,
yeah,
so black hole once it becomes a black hole, a lot of times black holes actually have
that's
gamma.
what I'm thinking.
You're
Never
thinking
mind.
of
I'm
the
thinking when two black holes spin around, they emit some crazy ass
yeah,
radiation.
they have well, so even regular black holes that are sucking stuff in, they get those gamma ray trails.
Hmm.
Now, what's I'm trying to remember, it's different, but it's different but the same. I I think it happens when I don't know if it's just all black hole creation or if it's when like massive objects fall in. But you ever heard of gamma ray bursts?
Hmm. Yep.
Yeah, it's like I mean, the chances of us getting hit by one are like It's like a
No,
blind person
almost
spinning around
zero.
a football field with a snub-nosed pistol and
Yeah.
like shooting at just randomly at seats, and you're in one of the 60,000
Uh-huh.
seats. Like, take that chance of getting hit and like quadruple it. Like, that's our chance of getting hit by a
Yeah.
gamma ray burst. But
And
it
what
would
what
it
what he's
would
saying
end
is
everything.
so what do you say of the gamma ray burst? It's yeah, this is things to keep you up at night. I don't know if I would call this one something neat per se, but I
Something
mean it's
neat.
kind of neat. It's
It's
kind of neat.
super neat. It's
It's
just
kind of neat.
it's a space laser beam.
Yeah, it's literally like so gamma rays are a type of radiation. There's alpha rays, beta rays, and gamma rays uh, of types of radiation. And gamma rays are, I believe they're the highest energy form of radiation because alpha rays are protons coming off, beta are electrons, I believe, and I think gamma is almost like just pure energy. I have to look it up. Either way,
It's
so you have
electromagnetic
these,
energy.
yeah. So you
It's
have this.
literally radiation.
It's just straight radiation. So well, I mean that's what like radiation is just particles or energy coming off of
It's photons.
something nuclear. So anyway,
It's
it's just
photons.
gamma radiation, and it's like ends in a straight line, and like you said, it just shoots out.
Yeah.
And if it were to hit us, it would just make everything explode.
Yeah, you would there would it would
Pretty much
like
just melt
burn it
us. It
would
would just
burn a
melt us.
ring through the atmosphere like onto the planet, and everything would just fucking die.
And at such a fast speed that we wouldn't even know what happened.
Yep.
It would just end.
And you're not seeing it either.
No, we would have no idea.
No,
It would just be over.
it is a world-ending event, but
Yeah.
it really only happens with like massive star collapses or like neutron stars merging.
Mhm.
It's like if you have like a binary system of neutron stars, when they do eventually merge, like that can cause one. Really,
Mhm.
anything that's just an insane release of energy.
Yep,
Black
because it
holes
has to go
merging
somewhere.
too. Black holes merging also sends out gravitational waves, which are super fun. Literal waves in
ripples,
gravity.
ripples in gravity.
God,
Yeah.
space is so fucking terrifying.
Well, even if you get past just the vast emptiness and the vacuum of it that you wouldn't be able to live in, or the complete cold that you wouldn't be able to live in, it's also literally everything is just trying to destroy everything else. Like that's really what space is.
Well, so space is super cold, but you'd live for like a pretty long time. Like if you
If you were
could,
just out in space,
as long as you can hold your breath,
no, because the pressures you would pop.
would be no. Tensile strength of skin is incredible.
Yeah, but you would blow up like a balloon. Much like Veruca Veruca Sweet?
What did
Veruca
I said Broomhilda, but I think that's Veruca.
it's definitely not Broomhilda.
No, Broomhilda. No, that was that's Django.
Brunhilde was
Yeah, that's
Django.
Django's wife.
It is Django's wife.
Yeah, because they
I
called her
love that.
Hildy.
That movie is fantastic.
That's off topic.
No, not at all.
We could do an entire episode on Tarantino movies.
Oh Jesus, we could. But I think it may be time. It may be
I
time.
mean, you were talking about exoplanets.
Honestly, I think it's a great segue going from exoplanets in the Goldilocks zone to then talk about aliens.
I can't get my hair to do the thing that the guy's hair does,
No, it's because you need way more product to make that happen.
or just shower less. I mean, to be fair, my hair's a little bit greasy right now, but it's because I've been wearing a hat all day.
So I'm going to preface this with I'm expecting to hear a decent number of things about ancient aliens right now. And I have never actually watched Ancient Aliens in my life.
No, I'm not going to talk about ancient aliens at all. Like I don't.
No?
No, because like, look, here's my opinion.
Mhm.
We can debate whether or not extraterrestrial life has visited Earth.
Yeah.
Now, do I think it has? Probably not. Like,
Mhm.
mathematically, we're not that interesting, and space is big, the galaxy is big. So, unless I will preface this number with an understanding that it might be a little bit off, but universe is like, what are we talking, like 13 point something billion years old based on like current teachings?
14.2, I believe. It's either 14.2 or
something like that. We're the fact of the matter is that we're probably wrong.
13.7.
13.7. I would
Oh,
literally split the
close.
difference.
Pretty damn close.
I said what you said 14.2. I said 13 point something.
Yeah.
James Webb Space Telescope is informing us that we're probably wrong because it's looking back so far that in the near like 13 billion light year area. It's finding like fully formed galaxies, and
Hmm.
physicists are like, you shouldn't fucking be there. Why are you there? You didn't have enough time to form. So we're probably wrong,
But like you said, if we're
but
seeing
we've seen
stuff
that
from 13 point something billion years ago, and like you said, it's already like looking at whole galaxies and not just like proto gas light shit,
yep
then
yep
it's
yep yep
been there for at
yep
least enough time
yep
to do that. So
yep
it's got to be longer. And
yep it's really throwing
it's
astrophysics
interesting.
for a loop right now.
Yeah.
There's not a ton of research on it because like it's just starting to happen. Like JWST is really, uh, we've said it before, but JWST being James Webb Space Telescope, the most advanced piece of telescope instrumentation we've ever had as humans ever.
Hmm.
Um, it is just throwing them for a loop, buddy.
Hmm.
But
Well, I
here,
mean, it makes sense though. Like every time we have something that's made to better see anything or like can like push beyond the limits of our previous instrumentation, that's when you find new stuff because we were limited before by what we could see and what we had and what we knew, and you have to build theories within the confines of what you can measure.
before we get into aliens, and we're about to get into aliens, I'm a chunk of the bottle down, which is this. To be fair, this is exactly where I wanted to be for when we started going into aliens. What do you think of after some numbers of sips before we
Yeah,
get into aliens?
we can do it before the aliens?
I'm just asking for your midway impressions.
Honestly, it's been fantastic. It's
It's
just
been
been
so good.
pretty nice sipping. This is like I said in the episode where we did Toki, that I'm like, you could just kind of put it back. Like, it's not something that you're going to sit there and sip and enjoy. It's like, it's more, you can put them away.
Oh,
This is a simple sip and enjoy and sit back. And, well, unless you're Anthony, and then you can just put anything away.
look, it's hey, we're good, buddy, because it's a lower proof than a lot of the other ones we've done, so it's not a
It
big
is a
deal.
lower proof. I'm talking more the flavor. This is much more, it's much heavier of a flavor, and it's really enjoyable to
Yeah,
just sip and let
but
it chill.
to your point earlier though, it's so clean that
Hmm.
it's so clean and it's so smooth, and you don't get a ton of the burn that it's easy to just go sort of just kind of go
It
at it.
is.
But tons of flavor, just
Yep.
so full.
Lots of flavor. But yeah.
Do you think aliens have bourbon? Like you know how like we
Oof.
think about like, all ancient, like how alcohol production is so synonymous with humankind? Do you
Mhm.
think that somewhere out in the cosmos there's other intelligent life that figured out how to mash
So
ethanols together, or do you think that, because I don't think life is special, but there's a chance that alcohol is special?
something special, the title of our first episode.
Something
Um
special out there.
I don't know what I think about that. Like I think that the way that I look at it is there are so many stars and so many planets that I feel like there's probably something that's almost identical to here somewhere. Like out there. I think that the probability is just there because of how high the probability is. Mind you, the probability that life forms at all and how it formed on Earth is like super low, like like it had to be all the perfect conditions at the perfect times with the perfect stuff for it to actually work. Like it's almost like playing craps or something and just getting the same dice roll every single time to keep it going for long enough to actually make life happen.
Well, I mean,
Like it's
maybe. I mean, at the like we've found inorganic, like not inorganic, but like was it asteroids or something where it's like sort of almost amino acids, like
yeah, we have potentially seen stuff, which is also one theory of how Earth got populated with life is there was some kind of amino acid chains or something on an asteroid that hit in the right place and then just began multiplying. Because something that also has to go with life is you have to be able to self-replicate. Like you have to be able to continue building more of you for you to continue living on. So that's even a part that, like, outside of just amino acid chains, you have to now also be a self-replicating amino acid chain, and you have to have some way of continuing your cycle and not getting destroyed, which is kind of where the whole cell, the membranes and walls and stuff come in down the road. But I
that's
digress.
no no
This
no
is the
you're
wrong episode for this.
no, but, like I challenge you a little bit on where when you're saying it's like mathematically if you
Hmm.
think about it in like human terms, it's super rare, or like it's like a
Hmm.
really low odd that life would like happen.
Hmm.
But the problem is when you look at the scale of the universe and you look at the time scale of the universe,
Hmm.
you're taking those statistical odds and you're stretching them so far
Yeah.
that you're almost shouldn't happen
Hmm.
becomes an inevitability. Like you're taking the you're like, what's the chance that this happens in 10 years? Zero.
Yeah.
What's the chance that it happens in 4 billion years?
Yeah.
Almost guaranteed.
And that's what you think. Like, I mean, even life on Earth, it's like it didn't start until what, 3.8 billion years ago, 4.2 billion years ago, or something like
Earth's
that.
only like 4.2 billion years old.
I think it's 4 point. Well, then it's 3.7.
No, earlier than that.
No.
Hold on. Point.
You want to bet a point on this one?
I don't think life. I don't
It's either
think
4.2 or 3.8 that cyanobacteria started.
you're saying 3.8. Well, 4.2 is the presumed age of the Earth.
Okay, so that's that one.
You're saying 3 point. I'm saying life. I'm saying life
Or is it
didn't
1.2?
start until like maybe like 1.2 billion years ago. It's in
It's
the
funny. It's
final. It's
funny
in the. I'm
because
thinking it's in the final quarter.
I have all of these amount of billions of years in my head, and I'm trying to put which one in line is which thing.
And for the record, I don't have
1.2
this looked up.
billion,
I'm
1.2
saying
billion
1.2
is
billion.
something, but I think 2.7 was cyanobacteria. It's either cyanobacteria or it's when no, or maybe 1.2 was
When the Prometheus
cyanobacteria.
alien showed up and threw his life eggs into the ocean.
Because cyanobacteria are the ones that could create oxygen. So they took the harsh. Yeah, so I think 2.7 was first life.
Okay, I'm saying 1.2. I think 2.7 we were still fucking molten rocks.
No, I was actually right the first time. It's 3.7.
Jesus.
Yeah.
Fine, I'll give you the point. You had it right. It's closest without going over.
Yeah, I'll take it because now we're even.
I swear to God, I thought it was like 1 point. I thought 1.2,
Nah, it's
like
3.7. It's and the Earth
3.7.
is
I swear to
yeah.
God, I thought we were still just like a molten rubble
Well,
pile.
so that's what's actually interesting is it was like that's where we started having like things like that, like just any kind of life form. But then let me see cyanobacteria. I think that's going to be 2.7.
You're saying the shit that started making atmosphere, but it had the
Well, so there was an atmosphere, but it was a very uh caustic atmosphere
yeah,
as
like
we see it.
methane, probably
It
like a
was
lot
yeah, it was
of
very like gross
yeah.
shit like that. And then cyanobacteria got to, or it was very like CO2 heavy. And then cyanobacteria were the first things that could do photosynthesis. So they took all that CO2 and converted it into oxygen, and that's what gave us the atmosphere that we can use. But in doing
What made
so,
the ozone?
ozone is just three. It's three
No. But
oxygens.
what made, because like until we had an ozone layer, the sun was a deadly laser. To quote one
I
of me and
think
Greg's favorite YouTube episodes,
if I
"Story of the World."
remember
Sun
correctly,
is a deadly laser.
ozone is a formation of when oxygen comes into contact with the upper layers of the atmosphere because it isn't shielded by
The sun is
this.
literally making
I
ozone.
believe it creates the
That
ozone. I
makes sense.
believe that's what happens.
The sun is a
Um,
deadly laser. So we just needed enough oxygen in the atmosphere to build up an ozone layer.
yeah. Okay. Yeah. So that's what. So the 2.4 billion that I was talking about
Yeah.
before was cyanobacteria.
Okay.
So yeah.
No,
So that was
you said you're right. Okay, I'm not.
yeah.
We can go back and look. Yeah, you're right. Okay, not
I might have said
1.2.
2.7.
The what
1.2 is what you said.
did anything happen at 1.2? Is that like when
I
shit
think that's
crawled on the
eukaryotic. I
land?
think that's eukaryotic or things with. It's either multicellular organism or
Eukaryotic cells.
eukaryotic, where it's things that actually have nucleuses.
Yeah.
First,
Deadly laser.
eukaryotes
While
on
he's
Earth.
continuing to look at this, it's important to remember that what we're talking about isn't necessarily how life would or could form on other planets, but certainly could, unless we were actually seeded by other aliens. Like, this is sort of how it happens. And I would argue that from what we see out in space is the same thing sort of like happening over and over again in different places. Like when stars form, there's leftover material that creates planets, and those planets are based on like we're like second or third generation, fourth, who knows how many generations based on what we see from JWST, but like all of the particles that make up life were originally thrown out into the universe by supernovas of other really big stars. The material we're made out of was not native to where we are. Some other
Mm-mm.
really big fucking star exploded, and enough carbon and gold and
Oh,
all the
elements.
other heavy elements were all made in
Mhm.
supernovas that predate the Earth's creation.
Yeah,
Like fuck nitrogen, like it's oxygen. It's too
all of
heavy.
it. Well,
It's just too heavy.
all of it comes from, like you said, what we would call the Big Bang. So the Big Bang is just not a great way to call it. So it's like a better name would be the cosmic expansion theory or everywhere stretch.
How is everywhere stretch
Better than Big Bang. I have no
better
idea.
than Big Bang? That doesn't.
Yeah, this is why we go to
It's the Big Bang. But again,
yeah.
might not have happened in the time frame that we think it happened. Thank you, JWST.
And also coming back on something we were just talking about, 1.2 billion years ago was complex life forms, multicellular stuff.
Sick. Okay, so I was like, I
There
was,
was some. It was like how I
yeah,
was saying I have like
yeah, I
multiple
had the
things in a
number.
timeline. I
Yeah,
have the numbers, but I can't remember which one goes with what
that's
number.
when shit crawled on land. Like, so but what we're talking about, like this, like slow progression.
Hmm.
It's the it is more space is there's 100 million stars in our galaxy, plus or minus a fuck ton. and
One or two metric fuck
and
tons.
there's one or two tons without the e, like the American ton,
Yeah, the
2,000
American, the
pounds.
TON, not
Yeah,
TONNE.
yeah, no, the American ton, 2,000 lbs, baby. Fuck your metric system. Light is in feet per second. Anyway, so and then and we're finding that based virtually all of them have planets. Like
Hmm.
formation wise, like that's just what happens. So when you see this, like these astrological things continually replicating under the laws of physics, like in my opinion, you have to assume that the other processes that we observe here are probably also replicating
Elsewhere.
elsewhere. It's
Yeah,
and based on its sheer size,
it's inevitable.
I totally get that like the chances that you exist are slim to none. But that slim to none expanded to like, 10 to the fucking 50th
Hmm.
is it's inevitable. There is a better
Yeah.
chance. I think Neil deGrasse Tyson said it. There's a better chance that every possible version of life exists than there is no other version of life exists.
Yep. Yeah, I do think that was Neil deGrasse Tyson. And then even like Stephen Hawking, who used to say he's like just the sheer size of the universe, the chances of it not happening are better or are
Way
worse,
lower.
way lower than chances of it happening. So it's just, I mean, you think about like even the lottery or something, it's like the chances of winning the lottery, it's so low, but somebody always wins the lottery.
Now, here's so whenever I talk about aliens, I think the best thing to always also bring up is, are you familiar with Fermi paradox?
Explain it to me. I think I know which one this one is.
Yeah, so Fermi paradox, it was originally proposed in the 50s by a dude named something
Fermi.
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 I think it was Enrico actually. That sounds right. Enrico
Enrico
Fermi.
Fermi.
Enrico Fermi. Why are
Mhm.
there no aliens? We look up in the stars, we don't see no aliens.
There must be aliens up there.
There must be, but I
Where's my
don't
pasta
see them.
fagioli?
Yes, where is the alien to try my fromage? Fucking Christ. I've had too much bourbon. So no, but Fermi paradox is basically like, if there is other complex life,
Mhm.
why haven't we encountered it?
Mhm.
Like, why haven't, because we're relatively young. So like we look at a lot of these other star systems, like
Mhm.
Proxima Centauri B, like a lot of these are also in like older yellow stars, or like some of them are orbiting, they're like closely orbiting like red dwarfs that
Yeah.
have, like, our star will live for like by our standards a relatively long amount of time. We've found planets orbiting stars that predate our solar system. So
Mhm.
you have to think, okay, like there should be something, and
Yeah.
it's close enough theoretically that we would have run into aliens. Like we're not
Yeah.
we're new kids on the block by
Mhm.
cosmic playground rules.
Yeah, so it's kind of like these stars have been around for longer, and these planets have been in the Goldilocks zone for significantly longer than we have. So why don't they have much more advanced life forms on them than us?
Yep.
So, yep.
Yeah, and it's not like we're not looking. Like we're trying to find.
Hmm.
Now the vastness makes it hard. So like when we sent like Voyager out, I think
Hmm.
Voyager 1 is now past Pluto finally.
I think so. Yeah,
Yeah. I think it's the first thing that we've sent outside of. I think it's the
the
first other than
actual
the manhole cover. I think that's the first thing that that's outside.
the manhole cover is like way past Proxima Centauri at
Yeah,
this
so the
point.
manhole cover, if the math is right and it didn't burn up, the manhole cover would be the third. At the time, it was the first fastest man-made
Yeah,
object in space. Now it would actually be the third. I think we've had two probes that we have actually accelerated faster
shot faster than that.
than it. Well, again, we think we don't actually know how fast it was going. Um, but
Yeah.
it's like we have like the disc on there that has like music from Earth at the
Hmm.
time and like drawings of humans,
Yeah, I
but
think,
that
and if I
shit
remember
is just like
correctly,
in the
it's
Oort cloud. It's not that fucking far.
no, it hasn't gotten that far out. Well, I mean, we just don't have the technology. It's kind of funny because it's in my mind, like just speculation wise, anything that we do now, we're gonna outstrip in 1,000 years, not even like a couple hundred years. So like even if we have something that's moving very quickly out into the solar system, as long as we stick on a path where we actually try to explore space, we're going to have something that moves much faster than that in the future. And so these things that were sent out a couple of hundred years ago, they're probably going to be passed by this future technology in the not too far future.
Oh yeah, you just gotta we'll just catch them.
Yeah, and it's kind of funny because I always think about that. It's like they're going to have these things with this old ass technology. Because if I remember correctly, like you said, the disc that they sent out, I think it's actually a like record. If I
Yeah,
remember correctly, that's like I believe it's is it gold? It's made out
mm-hmm.
of something
It's cool.
inert. Yeah, and they just literally just recorded on this record and just sent it into
Yeah, it's
space.
just like bird sounds, like
Just like
music.
random stuff, and then
Now we're
I think there's
assuming that
like
whatever finds it. I mean, it.
knows what to do and can play
Yeah,
it
and it's
somehow.
like, you know what? And when we sent it, it was so foolhardy for us to do that because,
Yeah.
like,
So
sure,
this is the
I
other
get
part of
it.
the
It's like
Fermi
the time. It's
paradox.
like the time capsule. So that's one explanation. Is just like, it's all so big
Hmm.
that we just like haven't found each other yet, and
Hmm.
that getting like even if we were to
Hmm.
going from one to the other, but you would still think that you would see signs of it because if there's somebody a million. Okay, so think about it this way. We've been sending radio waves out into space, detectable radio waves, for
100 years.
100 years, maybe 100 years, 150 years, somewhere in there. If you want to talk about like other shit we've been sending out into space, like messages and everything, maybe less than that. Like,
Like things that we actually are trying to send into space.
yeah,
Not like
but not
50 or 7,
intentionally,
probably like
but just
70
like,
years, something like that.
yeah, just like literally like radio waves that are like bouncing and like,
Hmm.
yeah, call it 70. What? To be fair, doesn't matter. Call it 100. Call it
Something like
all
that.
100. Doesn't
Yeah.
matter.
Time it has been going on for.
So the galaxy itself though, like Milky Way galaxy is 100,000 light years across, give or
Hmm.
take. So that's the problem. Is I have absolutely no assertions, no thinking, unless like some fucking deity level, like tier 3 civilization decides to like impart upon us their knowledge of the universe. Like human beings will never leave the Milky Way. Like conceptually, the idea that we're gonna go to another planet is mind-boggling. To like leave the galaxy and go to a different galaxy,
Hmm.
like short of just fucking waiting for Andromeda to run into us, which will happen sometime in the nearest future.
Yeah.
Like we're that's not going to happen. It's like
Oh yeah.
we got to go somewhere
Like,
else within the galaxy.
have you heard of the dark forest theory?
Oh, the idea that there's like some that like we haven't heard anything because everyone's super quiet because there's some like
Yeah.
invading force that we
Yeah.
need to be
So
aware of.
exactly. It's like the whole theory is that the universe is silent because the universe is hostile.
Yeah.
So any group that wasn't silent was taken over by these other silent hostile forces.
Hmm.
And then everybody that's quiet is still around. So if you're loud, you get killed off.
Yep.
But if you're quiet, you stay alive or you're hunting other groups.
It's literally that's literally part of the Fermi paradox.
Yeah, it's
That's
part of
like
the
one of the
it's
explanations.
one of them. Yeah, there's multiple
Um
explanations, but that one, the size one that you were talking about,
there's the
yeah,
zoo
it's
hypothesis where we've been found
we're yeah, and we're
and they're
just in a
watching us
cosmic
because we're not
zoo.
developed enough.
Yeah, 'cause we're stupid.
They'll scare us. And then there's like sort of like the other one, the great filter, where so in the same way that the expanse of time makes life an inevitability,
Mhm.
that same amount of expansive time makes a like civilization ending event an inevitability. So life in the long scale is rare
Yeah.
because it gets wiped out before it ever gets to leave the planet.
Hmm.
Which is
Yeah, because
which is why I'm such a proponent of dumping so many resources into extraplanar within the solar system, but even more so than that, like theoretically we like are you going to get somewhere quickly at the current moment? No.
no,
But do we technically have the ability to put enough people on a ship that has regenerating food sources, regenerating water, regenerating air at 5% the speed of light and ship them off to an exoplanet? Yeah,
and
probably.
say and just wave and say good luck.
Yeah.
Like,
No, like I mean, is that that wrong?
mhm. No, I mean,
Like
I see what you're
is that
saying.
an absurd? I think we
You would have
have
to
the
have
tech for
people that are
that.
going to. Yeah, I mean, you'd have to have people that are going to volunteer. Excuse me,
No,
that are
with
actually
a
going to volunteer to
yeah.
go do that. Which
You don't think we could find people to fucking volunteer for that?
I'm sure we could definitely find
I'm
people to
sure we
volunteer for
could.
that.
Well, I mean, now it has to be a big craft.
Mhm.
So, like, I mean,
It's going to cost money, and
tons of
nobody wants to
money,
put money into it.
tons of money. And I don't, when I say that we have the technology, I mean, I think we
Yeah,
because,
loose.
yeah, I'm saying that loosely. Like, we would have to build it in space. A lot of the shit that I'm saying, like, would need to be developed. But I think we have
Hmm.
the technology is not the right word. I think we have the capacity for it.
Hmm. I mean, we have the I think our technology is advanced enough to make the things we would need to do it. I think that's what you mean.
But to build a ship big enough to realistically do it, you would have to
Hmm.
build that ship in space.
Well, that's what I'm saying. I think we have the technology that we could make the things we need to build it in space. Like I think it would be possible to do it
Yeah.
with what we have now. We'd have to like make new things to do it, but we
But I
would
think we
like we'd have
could
to make
do it.
like small space station. Like we'd have to figure out how to like retrofit the space stations or something with some kind of a dock that you could like literally build off of or something
Well,
like that.
it have to. The problem is, it would have to be bigger than that. You would
Well,
need to take enough. Well, ooh,
we just need something stationary that we could get all the materials up to because once you get it into space and you have it orbiting at the same rate as whatever you're attaching it to, like the size is pretty doesn't really matter.
not. Well, yeah, no, that's 100% true. But I'm also thinking that you could also do like frozen gametes. I think they did this in Interstellar. Like that was like their plan C.
Uh-huh.
Like you do like frozen gametes, and then the problem is we would have to develop like cryo freeze technology, like in
So again, we're gametes are just reproductive cells
wait, is that for
and
the
break.
purposes of the listeners?
That was for the purpose of the
Yeah,
listeners.
you're right.
I
You're right. You're
figured
right.
you
You're
know
right.
what gametes are.
I know. Considering I said it first.
Yeah, yeah. I figured you know what you were saying.
Yeah. So, but I'm just like you could have like frozen eggs, frozen sperm, and
Hmm.
then if we if we were to like spend the next 20 years really working on like metabolic freeze,
Hmm.
that's a ship you could send because then you don't have to worry about like a whole culture forming on a ship because between here and Proxima Centauri b at 5% the speed of light, we have now gone through what is the inverse of that equation? 4.2 light years at 5% the speed of light means that you would
20
be
years
going
per
90.
light year, so 20 times 4
No, it's
point.
95 times 4.2.
Wait, 5%.
If you're going 5% the speed of light, no, my
Well,
well,
five no 5% is 1/20th.
No, 5% is. Oh yeah, okay. So 20 times 4.2,
Yes.
right?
Yep.
What's 20 times 4.2? So 80. You'd end up with like
840
3 generations. You'd have
years.
to do like 3 generations on the
Or no,
ship.
84.0. Yeah.
So you'd end up with like 3 generations on the ship.
So it's going to be a completely different culture, like you said, than left. The problem with just sending like kind of frozen gametes and stuff is like you're sending the basic building blocks to do something, but like once it gets there, now what?
Well, no, that's what I'm saying is you would have to do that and also send adult
Oh, you'd have to do
people
both.
for like yeah, like suspended animation
hmm
basically.
mhm.
Send it with like the gametes. So you send it with everything you need to set up a base colony and to manufacture. And then I mean it's essentially this is what we're gonna do for Mars. The only difference is we're not gonna send the gametes. Like
Yeah,
we're gonna pre send like pods and
which is
manufacturing stuff, and then you
also
send people.
I'm also trying to think what's the point of sending the gametes if you're sending people, since we all have the gametes already.
It's because how many people are you gonna send?
Oh, you're saying like you would send a lot of them, so then, so wait, no, you would be sending, you would need a surrogate or something. Like you can't just make humans out of sperm and eggs.
If we get to the point where we can stop a body from aging in a tube, you're telling me that you
We
can't
can't
have a
test tube
fucking
baby,
humid pod?
test tubing that baby. Yeah.
Yeah,
No,
like but like
like I'm
in
just picturing
all,
the Matrix, just picturing the Matrix with all the people in
yeah,
the things.
yeah, that's what I'm
Yeah.
suggesting. But we could like the problem is that's like crazy unethical, but we could absolutely
Mhm.
do it. Like
Yeah. I don't know about
I think
that, but
today's technology, literally today's technology. This is not the other thing. Like today's technology, we could absolutely just grow a full ass human in a test tube.
I think everything that we have just said we could probably do with today's technology.
I don't know. I don't know how you would suspend and reanimate somebody. I don't think we're there
I'm
yet.
sorry. I'm sorry. Besides the suspended animation, everything else we could do.
So
I
anyway,
think
so
it's really interesting that we have
exoplanet
come.
wise, that's the only way I think you could do it.
Yeah. Well,
Realistically, if like you could
I
have just
think
like,
I
but
think
you would have to have like birthing sections and doctors. You would have to take
you
so
need.
many people if you weren't freezing a number of people and then taking a population base in the form of eggs and sperm.
Mhm.
Because
So
even if you take 50 people, the genetic diversity is going to be like hard to make sure you propagate because you're probably going to lose half of them on the voyage.
So I think the way that you would have to do it is you would have to literally be sending, if you're going on that kind of a journey outside of the cryogenesis kind of thing, which I think you run into all kinds of other issues with that kind of stuff because then you're running into, there's a problem, a malfunction, like people wake up incorrectly, people like, I feel like there's a lot of things that can potentially go wrong in that.
Robots.
So outside of using that kind of a thing, uh, I would say that you would have to literally have just a colony that you're sending, and the colony has to be self-replicating. Pretty much, I mean, you watched Fallout, but pretty much like a
Yeah.
Fallout vault,
Yeah. See,
just in the sky.
you're thinking like Fallout Pod, Fallout Vault, like colony ship. I'm
hmm
thinking more. Did you ever play Horizon Zero Dawn?
hmm
I'm thinking more like Horizon Zero Dawn, where it's like everyone's gonna die. We know
hmm
everyone's gonna die, and then
hmm
we have preset
Uh,
robots and shit.
I'm just remembering I didn't finish Horizon Zero Dawn, so I think you're
So I just
probably
ruined the whole like
spoiling Horizon Zero Dawn
spoiler alert.
a
It's like
little bit late.
yeah, it's like fucking clone. It's like clone tubes that are like raised by like robots.
Well, anyway, I think we have cycled around and gone through some really interesting parts of the universe. We have not only touched on that, but we've gotten to talk about Anthony's favorite aliens. And then we even came back around to talk about cool stuff on Earth that we could potentially do
To
to
populate other
get to
planets.
these planets and repopulate them. Honestly, the things that we could talk about with the universe are as vast as the universe. But looking at our time here,
Oh shit.
we're getting up there.
Oh
So
fuck. We didn't even get to the Asimov's Tears of Civilization I wanted to talk about.
I think we're gonna have to maybe have it for a part two down the road.
Well, we can definitely do like an alien Asimov robot part 2 though.
I think we should definitely do an alien episode.
We're definitely gonna do like scary things in space that
Hmm.
should keep you up at night.
Yeah.
And we'll title the episode like something scary out there
Something
and
disturbing.
something to keep you up at night, and we do like a coffee liqueur.
Ooh, that sounds fun. Or just espresso martinis.
We
We'll do a
just
brunch.
drink
We'll do a brunch episode.
just waffles and espresso
Espresso
martinis,
martinis, just
and
a
we're just
fucking
talking
brunch,
about
and then talk
planet
about.
enders.
Perfect. All right. So again, we went through the universe. We went through the dark and mysterious. What are your final thoughts on the dark and mysterious in this glass?
Oh, it's so dark and so mysterious, and I had so much more than a wee dram. I think I attribute my lack of gingivitis and other gum-related diseases to the amount of overproof whiskey I drink. I think it just kills all the
Just
bacteria.
swirl it around.
Just swirl it around. It's basically it's like mouthwash, delicious
Yeah.
barrel-aged mouthwash. So my tasting notes are the same. It's wood.
Mhm.
It's
Yeah.
it's woody. It's oaky.
Hmm.
It's smooth as all hell. The teeniest bit of bite. If you're not a big bourbon drinker, you're not gonna love it because this is like the root of what your oaky bourbons are supposed to taste like.
Hmm.
All of that said, if I had to put a 1 out of 10 out of this, do you remember what I gave? No, because we didn't do it. We didn't do numbers on it.
And
The
what?
the the McKenna, the Henry McKenna, or the
No,
Four
we didn't.
Roses. No,
Nope.
we were like ranking those at the time. I think it's like right there with Four Roses single barrel, as far as how much I'm actually enjoying drinking it.
Hmm.
So I'm gonna like I'm thinking like high seven, low eight.
I think we're gonna be in a similar realm on
Yeah,
this one.
I'm gonna go 8.2. No. What? Well, your smile like, makes me think that you were also going to say 8.2.
I was going to say
Ah, fuck
8.2.
that. I'm going to leave it at 8.2. I was thinking about dropping it a little bit, but I don't think I want to.
Because I
I
think,
think 8.2 is like right where this should live. And for like
because
a
if I'm,
$50 bottle, that's like.
it's not bad at all. I
All right, yeah,
mean,
please give me your final notes. I talked for
yeah.
like way too
So
long cuz I'm drunk.
again, final notes. I'm gonna keep it short and sweet. I think the same as you. It's same as beginning. It's very woody, got a little bit of smoke to it, but again, I think I got mostly the oak character, and I find it delightful. So I would also give it an 8.2, because I think it's not quite the 9 that Takatsuru was, but I think it definitely deserves well above the 7 that I gave Toki.
Delicious shit. This is the type of bourbon you and I like.
Definitely. And this conversation, I think, is also the kind of conversation we enjoy. I honestly want to get more into the aliens and do definitely at least a couple fucking conspiracy theory episodes. I just think it'll be a lot of fun. All
Yeah.
right, dude.
Cheers, buddy.
Cheers, sir. I'm a little drunk.